Hi, Tridell. We're going to go ahead and try doing a quick and dirty video on the rock cycle so you can see what's going on, because this is something that on the test you're going to have to be able to reproduce. So if you look on Google Classroom, I'll put a completed copy and I'll put a blank copy up on Google Classroom after I'm done with this video. And then we will, you'll have a chance to follow along and see how this all gets put together. So let me take just a second and start the presentation. Oops, I have to switch cameras first. So let me switch to, I'm going to keep my face off of it because I need the room on the screen to begin to allow you to see everything. So just a second, we'll get going. This is section 3.1. Like I said, we're going to start with just a really blank piece of paper here, basically. And we could pick any starting spot that we wanted to on the screen. I'm going to pick igneous rocks, and we'll go from there. And we know the three main types of rock. We know our igneous, sedimentary, and metamorphic. And the whole goal of the rock cycle is to show how these can transfer from one form to another. Okay, so we know that we have igneous rock, and if we kind of follow the path over, for igneous rock to end up as sedimentary rock, first thing that has to happen is we have to have sediment. So the question is, what processes would cause the igneous rock to turn into sediment? Well, we know that is weathering and erosion. Okay, igneous rock gets exposed to the weather, whether it's physical or chemical, it doesn't matter. We're just talking about weathering and erosion, and it turns to sediment. Okay, with sediment, in order to get sediment to sedimentary rocks, we know that the processes that happen are cementation and compaction. Remember, those are part of lithification. Okay, and that's what forms a sedimentary rock. Okay, to get from sedimentary to metamorphic, we know that metamorphic rocks need heat and pressure to transition to something else. After metamorphic, it looks like we're on our way over to igneous, and for that to happen, we have to have magma to form an igneous rock, which means that we have to have melting that happens. Okay, we have to go from a metamorphic to a melted rock before I can go to magma, and before I can get from magma to an actual solid igneous rock, the cooling and crystallization has to occur. Now, it would be really nice if it followed this nice easy circle all the way around and repeated the process over and over and over, everything in the same order. We know that's not going to happen. We know that not all igneous rocks end up as sedimentary rocks. Not all sedimentary rocks end up as metamorphic. Not all metamorphic end up as igneous. So we have to look, there's some different paths that are going to be on the rock cycle that are not on this nice little circle. And remember, the ultimate goal here is to be able to fill this out for the test. I'll give you 3 or 4 of the pieces, and then you'll have to fill in the rest. And I want to start here with sediment, because that was the first place where we actually kind of began to break things down. Now, we know that we have lots of different sizes of sediment. We have everything from baseball-sized rocks down to almost microscopic clay. Well, for that to happen, that sediment, for it to get smaller and smaller, has to continually go back into the weathering and erosion. If I have a big chunk of rock, it has to go back into weathering and erosion before it can get made into smaller and smaller chunks. Cementation and compaction happens, and then we get to the sedimentary rock. Just like any other rock, a sedimentary rock can be weathered and it can be eroded. And when we look at it, if you think about it just a little bit, we can look at metamorphic rocks, and just because it's a metamorphic rock doesn't mean it has to melt. If it gets exposed to physical or chemical weathering, you got it. We're going to go right back to weathering and erosion. So there are 3 different paths back to weathering and erosion that aren't on this main loop. Now let's go back to metamorphic rocks, okay? As we talked about, just like sediment can go back through weathering and erosion, and we talked about in class, depending on the type of rock, it can go back and be exposed to heat and pressure several different times or for an extended period of time and make a different kind of metamorphic rock. So for that reason, we can go from metamorphic right back to heat and pressure, okay? And metamorphism can happen. Sedimentary rocks are not the only rocks that can undergo heat and pressure and become metamorphic rocks. Igneous rocks can do the same thing. There's a path that goes from the igneous rocks over to heat and pressure, and they will eventually form metamorphic rocks. Okay. Look at igneous rocks, and igneous rocks, if you're seeing a pattern here, you're seeing that there's this kind of looping back that goes on. Once an igneous rock cools and crystallizes, it can absolutely be melted down again. It happens all the time, especially around active volcanoes, where you have igneous rocks that get exposed to heat again, high amounts of heat, and they begin to melt. Now, it's not very common, but we also know the same thing can happen to sedimentary rocks. A sedimentary rock, if magma or lava rolls across it or through a layer of sedimentary rock, that sedimentary rock, just like any other rock, can be can be melted and eventually form an igneous rock. So you start to see these different loops. There's 3 paths back to weathering and erosion for each of the main 3 rocks, okay? They go directly to one process, but they can also cut across to the others. Igneous can go to melting. Igneous goes to weathering and erosion. Igneous also goes to heat and pressure. Sediment goes back to weathering and erosion. Sedimentary rocks can go to melting. The sedimentary rocks can also go back and be eroded again. Metamorphic can be exposed to more heat and pressure, and it can also be weathered and eroded. So there's lots of different ways that this can happen. It's called the rock cycle, but it's called the rock cycle because there's really no beginning and no end to the process. All rocks are at some point in this, even though we don't see the rocks change very much. Remember, we're talking about the geologic time scale here. We're not talking necessarily about the day-to-day life of a human. So all rocks are moving through it. Think that geologic time. And the key thing, and this is why we have all these different ins and outs and all that kind of stuff, is there's not a fixed path that needs to be followed. Just because it goes around in a nice circle doesn't mean that's the way it actually has to go. So let me transition back. Oops, let's bring back my face. Like I said, be prepared for, sorry about that, I hit the wrong button. Be prepared for seeing this on the test. You'll be given the Bayer rock cycle and you'll be asked to fill it in. And if you have questions, email me or let me know when you get back and we'll go through and we'll clear up any questions that you have. Till then, I hope you're feeling better and I hope you have a great week. See you later, Tridell. Bye.